Hello everyone, welcome to Unravel Logic channel. In our previous video we explored the arithmetic mean. In today's video we'll be learning about median. So let's start with the formal definition. Median is one of the fundamental measures of central tendency. I know in the video of arithmetic mean I also said the same definition, but yeah, that is true. So median is also one of the fundamental measures of central tendency. So let's write it down. One of the fundamental measures of central tendency. Let's say that in an ordered or sorted data set, median is the middle value, right? So ordered set or sorted, median is the middle value. So this ordered set or sorted set can be a set of numbers, yeah, or it can be an ordinal data. Ordinal data is a data which is naturally ordered. For example, rating data, right? So the rating can be poor, good, excellent. So this is an ordered data. So in this case, the median will be the middle value. In our rating example, poor, good, excellent, good will be the median, right? So something like that, yeah. Median is basically the point that divides the data into two equal halves. Now you must be thinking that we already have mean, why do we need median, right? So first let me write this thing. Median is the point in the data that divides the data into two equal halves. So why median when we have mean, right? Why median, right? The answer is outliers. Outliers. This is why we need median in most cases. Since mean covers every data point in the sum, it tends to get affected by the outliers. So remember, if you remember the formula for arithmetic mean, we total each number, right? So 1 plus 3 plus 7 plus 2 plus 1, right? So we are summing every number. So for example, in this case, if 7 is the outlier, our arithmetic mean would get affected by this outlier, right? I also need to divide by 5, right? So this arithmetic mean will get affected by this outlier. So 7 is an outlier, right? In case of median, the median doesn't get affected by the outliers, because median being the middle value in an ordered set, it doesn't get affected by a very small or a very large number in the set. We did study that outliers don't really reflect the typical value, so we can use median to avoid them. It gives us that middle ground. Now let us Now I will demonstrate you guys how the median doesn't get affected by the outliers, but before that let's see the mathematical formula first. Okay, sorry, chose the wrong color. So mathematical formula. It's not really a defined formula, it is a process as such. So there can be two cases broadly. So let's talk about case 1. Odd number of data points. So in our data set, let's say we have odd number of data points. Odd number of data points. Let us consider a set of odd data points and find the median. Let us also have some outliers in the data that we'll be using. Okay, so let's say this is my data. So my data is 10, 9, 11, 8, 12, 20, 25. Let us first sort these numbers, and the sorted set would be 8, 9, 10, 11, 12, 20, 25. Now this 20, 25 outliers, we can see that clearly. Yeah. Now, which is the middle value? Let's eyeball this. Which is the middle value of these numbers? The middle value is simply this 11. Yeah. So this is the median. As you can see, we didn't calculate, we didn't sum, or we didn't divide anything, right, like we did in arithmetic mean. So naturally, if we are just looking at the middle value of the data set, of the ordered data set, it doesn't get affected by outliers. We didn't do any calculation, and we didn't include 20 or 25, which are the outliers, in our calculation, which we didn't do. So naturally, this number that we are selecting, which is the middle value, by definition is the median, and it doesn't get affected by outliers. I will say again. Yeah. So let us anyways derive a formula, so that you don't have to do a lot of calculation in case there are a lot of numbers. Yeah. So if there are a lot of numbers, hundreds or thousands of numbers, how would you calculate the middle value? Yeah, you cannot eyeball it just like we did in this case. So the formula is something like this. Odd number case. Formula is n plus 1 by 2. This formula will give us the index or position of the median in our data set, right? Index or position of the median in our data set. Let's try this on our data set. So 8, 9, 10, 11, 12, 20, 25, and let's put the positions 1, 2, 3, 4, 5, 6, 7. So n is nothing but number of data points. Yeah. So let's apply the formula, which is n plus 1 by 2. So 7, we have 7 data points, plus 1 divides by 2, 4 is the index position, so this 4 matches with this 4 and in turn gives us median as 11. Okay, let's do case 2. Even number of data points. Now this is a little bit tricky or a little bit complex as such. Not tricky, it's very simple, but a little bit, it has an extra step basically. Yeah. So now let us consider a set of even data points for our example and find the median. So this is the data points: 10, 9, 11, 8, 12, 20, 25, 9. Now let us sort these numbers before we proceed. Okay, so we have 8, 9, 9, 10, 11, 12, 20, 25. Again we have two outliers. The same outliers as the previous example, but you get the point. So the middle value in this case would be the average of the two middle values, because in case of even numbers, if you try to divide the data set in two equal halves, you won't be able to, because there are even numbers, and if you if you try to find the midpoint, it wouldn't really exactly be the midpoint. Yeah, so the way you will have to do is, so let's try this here. So how many number of data points we have? One, two, three, 4, 5, 6, 7, 8. So if you divide 8 by 2, you will get the fourth position: 1, 2, 3, 4, right? And if you make this fourth position as median, it is not really exactly dividing the data set into two equal halves, because on the right side you have 4 data points and on the left side you have 3 data points. So this is sort of incorrect. Yeah, this is not right. Okay, so what do? So the formula when we have even number of data points is n1 is equal to n by 2, n2 is equal to n by 2 plus 1. What are these n1 and n2? These are two middle numbers. Okay, and these things will return the index positions. Okay, index position, or I should write it as index simply. Okay. All right. Now the formula goes something like this. Okay, so number at n1 plus number at n2 divided by 2 equals median. This is nothing but the arithmetic mean formula for the two middle numbers. Okay, as simple as that. So let's try and find it out. Okay, so we have 8, 9, 9, 10, 11, 12, 20, 25, and let's put the index positions. So we have 1, 2, 3, 4, 5, 6, 7, 8 even numbers. Now let's work through the formula. So we have n1 is equal to n by 2, so that is 4, yeah, so that would be 8 by 2, so 4, and then n2 is equal to 4 plus 1, because n by 2 plus 1, so 8 by 2 is 4 plus 1, we have 5. Okay, and let's now apply the formula. Number at n1, which is 4, plus number at n2, which is 5, and then divide by 2. So 5 plus 4 is 9, divided by 2, which gives us 10.5. So this is the median. Okay, so two middle numbers, this gives us 10.5. Okay, this is the median. Okay, now let's understand the mathematical intuition behind median. Why median? What does it actually do, right? Intuition. Let us understand what it means to calculate median. Let us assume that we have a group of people. Yeah, so we have a group of people, and listen to me carefully to understand this example. And we want to elect one person from that group who would best represent everyone. Okay, group of people, elect one representative, just like elections. Okay, we have a group of people, we elect one person who represents everybody as best as possible. We represent each person with a number. For example, in our case, let's represent each of those persons with a number, and the numbers are these. So we have 8, we have 9, 10, 11, 12, 20, 25. The numbers are also representing ideology or values. So each number represents their ideology or values, or magnitude of their ideology or values, right? So number also represent the person's ideology or values. Okay, a representative should be such that they should be closest to all the other people's ideology or values. So we need to select a representative number, or a single person who will represent all these other numbers, or a single number who would represent all these other numbers in such a way that that particular number should be closest to all other numbers, right? So let me repeat in our analogy terms. Representative should be such that they should be closest to all the other people's ideology or values. So let us try and elect number 20 to begin with. Okay, so let us elect number 20, or the person representing 20, we can say. Okay, so let's try and make a simple diagram. Okay, so and let me do it let me do it separately. Okay, here. Okay, so we have 8, 9, 10, 11, 12, 20, 25. Okay, let us do the calculations. Okay, so we're electing 20, so let's circle 20. And how far is 20 from 8? Okay, How far is 20 from 8? 12 values. Okay, 12 values or ideology. Okay. How far is 9 from 20? 11. Okay. How far is 10 from 20? 10. How far is 11 from 20? 9. How far is 12 from 20? 8. And then how far is 25 from 25? So you see these numbers, the distance between 20 and other numbers in some cases is too much. Okay, so we can say that 20 doesn't represent all other numbers fairly, and it seems to happen that 20 is an outlier as well. So this basically explains the reason to choose median, right? Because since 20 isn't the right value, right, and it also happens to be the outlier, this should not be the median, correct? Now we all know that the median would be 11, right? But I just wanted to show you folks that if we select the wrong number, right, it wouldn't be a good representative of all the other numbers. Okay, and that number should not be an outlier for sure. Okay. Now same will be the case if we selected if we had selected 8, 25 or 9. So if we had selected 8 or I should not just put this. If we had selected 8 or 25 or 9, this wouldn't have been the right number as well. So as I said, the median gives us the value 11. So let us try and check all this with 11. Okay, so by selecting 11, so 8, 9, 10, 11, 12, 20, 25. Now we select 11 is the median, and let's see the differences now. Okay, so difference from 8, 3, difference from 9, 2, difference from 10, 1, difference from 12, 1, difference from 20, we have 9, and then difference from 25, we have 14. So if you see, if you compare these cases, right, these numbers 3, 2, 1, 1, right, and even 9, right, we have 5 numbers which are close to 11, right? We have only one number which is 14, which represents a very high number, 25, right, in terms of difference from 11, right? So only one number. In the previous case, when we had selected 20 as the fair representative, right, 12, 11, 10, 9, 8, almost all the numbers were higher, right? So we can clearly see that why 11 is the right choice, and it clearly doesn't get affected by the outliers, right? So this is a fair representative, and this is what we would select in our elections. Okay, so median gives us a number that is closer to all other numbers in the set. Median gives us a number which is closer to all other numbers in the set. It will minimize the sum of absolute difference from all other numbers. So let me repeat. It will minimize the sum of absolute difference from all other numbers, because it is the middle point. Because median is the midpoint. Sort of like the circle analogy, right? So the center of the circle, right, is equidistant to all the other points on the circle, and if you shift the center of the circle somewhere else but you keep the circle at the same place, then it wouldn't be equidistant anymore, right? So median is something like that. It's the center point of all the other data points. Okay, this is why in case of outliers, median can be a better choice than mean, because mean gets pulled in the direction of outliers and median doesn't, because it is position based. So this is a very important point. Average is not position based, it is based on the sum of all the numbers, but the median is position based, so it doesn't get affected by the outliers. This is an important point. Okay, and you can validate this statement which I mentioned, right? It will minimize the sum of absolute difference from all other members. You can sum all these numbers on our previous example, this example. You can sum all these numbers and you can sum all these numbers. This sum would be minimum, right? And this sum would be large. Okay, so let us take a simple example. Okay, let us analyze incomes of the employees of a company. Incomes of the employees of a company. $20, $25, $30, $35, $40, $45, $50, $60, $70 and $1,000. Now all these numbers are in figures in $1,000 Okay, so this is $20,000, this is $25,000, and this is, you can say, okay, so this is a very high number. So this is sort of an outlier. Okay, we can clearly see this is an outlier. Okay, this is way higher than all the other numbers. Now let's find the average. Okay, since we are comparing with arithmetic mean or average, so let's try and find out the average. So average is 137, okay, which is again in $1,000. Okay, so $137,000. All right, clearly this doesn't represent the typical income of the employees, right? So if you eyeball the data, right, you can clearly see that only one employee has that much amount. Even you can say that only one employee has income which is greater than 100. Okay, that is this outlier. So how can we say that average income of all the employees in this company is 137? That is a very wrong number, very much affected by the outlier. Now let us find the median. Let us see how median can help us in this case. Okay, median would be 40 plus 45. These are the two middle numbers, because this is the case of even numbers, 1 2 3 4 5 6 7 8 9 10. Yeah, divide by 2. So this is arithmetic mean of the two middle numbers, which is 85. We divided by 2, we get 42.5, again in $1,000. Okay, so this is our median. Now we can say, we can again look at all the numbers in this set, and we can clearly say that median is the correct value. So 42.5 seems like a good representative of all the numbers, and this doesn't get affected by the outlier, which is 1,000. Okay, let us take another example. Okay, so let us see now example of ordinal data, right? What happens in case the data is ordinal? Ordinal data. Okay, data having natural order. Okay, For example, let's say the rating data: poor, fair, good, excellent. This is ordinal data, because the ratings have a natural order. So poor is very bad, fair is a better than poor, good is better than fair, and then excellent is the best rating. Okay, so this has an order. Okay, you can sort this and it would make sense. Okay, so let's have the actual data now. Okay, so poor, fair, fair, good, excellent, and you can see that this data is already sorted. Okay, now how many number of data points do we have? 1 2 3 4 5 6 7 8 9, right? So odd number case, so we can simply do 9 plus 1 divided by 2 and 5. 1 2 3 4 5, so 2 3 4 5, so this would be the median. Okay, this divides the data into two equal halves, so 1 2 3 4, 1 2 3 4. Okay, so this is the median. We cannot find average of this data, so median works best here. There is no other option as such, right? This is an example of ordinal data, as I already mentioned, and the median is the rating fair. So you can say that in this data the median rating is fair, okay, which will directly tell you that median rating or the fair rating is the best representative of all the ratings in your data. Okay, so you can say that fair rating wins in terms of frequency. The fair rating occurs the maximum number of times, is what you can say. Okay, so when to use median in place of average? Let's summarize this. Okay, like, or let me use the right color. When to use median? Okay. First point is ordinal data, when the data is ordinal. Okay. Second is, we know that our data has outliers. Okay, in case our data has outliers and we know it, we should use median. And another thing that I should mention is, if outliers can be discarded. If the outliers cannot be discarded, then I think it will be best if you calculate average. But you can also calculate median, and then you can write a note in your analysis that this is the average, this is the median, and then the one who is reading your analysis can conclude for themselves that which one would be the better number, depending on what kind of data you are calculating the median or average on. Okay. In some cases we can discard outliers and take the mean, right? Outliers can be discarded in cases when they are result of a measurement error. Okay. Outliers can be discarded in case of measurement error. In such cases, can also use mean. Mean, median will be close in such cases. Okay. So that's it, guys. Thank you for watching. Like, share and subscribe as much as possible. I will create more content like this. The topic for the next video will be mode, And if you're wondering I didn't show any visuals in this video, is because it's kind of a comparison from arithmetic mean, right? So if you watched my video on arithmetic mean, you would be able to visualize this automatically. Okay, but yeah, I would leave it up to you to plot some data points, some dummy data points on paper, and try to see where the average would lie and where the median would lie. Okay, and how will it get affected by the outliers. Okay, thank you again for watching. Like, share and subscribe.